For years, AI coding assistants have operated at the line level, waiting for your next keystroke to suggest a small block of text. Today, we are looking at systems that read your entire repository, build and configure themselves, and execute complex logic independently. Our goal in this workflow is to move from a completely blank terminal to a fully tested, cleanly committed pull request without manually writing a single line of code. To execute this, you need exactly 4 things ready on your machine: a system terminal, Node.js, an Anthropic console account configured with API billing, and a local Git repository. By off-roading the manual keystrokes to an autonomous agent, your daily role shifts. You stop acting as a code typist and take on the responsibilities of an executive reviewer, steering the logic from a high level. We begin inside a local project directory. In this specific repository, we have a known reproducible authentication bug that needs patching. To bring the agent into this environment, we run a single command to install the package globally: npm install g at anthropic.ai/Claude Code. Once installed, running the tool prompts a browser-based authentication process. This securely links your local command line interface to your Anthropic credentials, ensuring the agent has the necessary API access to function. Now we issue an agentic prompt. Standard chatbot interactions are usually open-ended conversations. An agentic prompt operates like a strict set of software specifications. To succeed, this prompt requires 2 non-negotiable elements. First, you must explicitly declare the target files to constrain the agent's focus. Second, you must define concrete verification criteria so the agent can check its own work. Looking at this terminal interface, we see those rules in action. We specify that the bug is located in src/auth.ts. We describe the patch required, and we command the agent to run npm test to verify the fix before reporting back. When you treat the prompt like a specification, you remove the ambiguity that often leads to off-target edits or hallucinated logic. The system initiates the agentic loop: gather context, take action, and verify results. Gather context uses agentic search to map project dependencies. Take action executes coordinated edits across multiple files. Verify results runs tests. If they fail, it loops back to correct the code. Giving a system independent control to rewrite local files and run commands naturally raises security concerns. You don't want an automated process breaking a stable environment. To mitigate this, the system utilizes a built-in permission gate. It actively pauses and requires your manual approval before executing potentially dangerous bash commands or modifying critical system files. If an edit does introduce an unwanted change, you have an instant rollback mechanism to safely protect your progress. By typing /rewind or hitting the escape key twice, you restore the affected files to their exact previous state. The presence of a verifiable loop and a guaranteed rollback mechanism creates a managed environment, allowing you to oversee autonomous coding without the fear of permanent project corruption. Once the internal test suite passes and the fix is verified, the agentic loop finishes. Now we hand the process off to version control. Because the agent shares your terminal environment, it can execute Git commands directly. It automatically targets and stages the newly modified files. It pulls from the context gathered during the editing phase to author a comprehensive commit message, accurately summarizing the logic changes it just implemented. Finally, it pushes the new branch to your remote repository and opens a pull request. Unifying code generation and version control inside a single autonomous workflow removes the final manual friction point of shipping a feature. You open your browser, and this is what awaits you: a fully documented pull request, complete with passing continuous integration checks, ready for a final human review. A bug fix that previously required manual discovery, line-by-line typing, local testing, and Git wrangling was resolved with a single, precisely structured prompt. For complex architectures, you can extend this capability further using the Model Context Protocol, or MCP. This diagram illustrates how MCP operates. By configuring local servers, you give the CLI a universal protocol to securely query internal databases, pull context from Slack workspaces, and read external APIs directly within the agentic loop. With these systems connected, you are no longer constrained by manual code entry. You dictate the logic, define the constraints, and let the agent orchestrate the execution.